Hello NSA student, this is Mr. Hinton with the Math Department. One of the most frequent questions that I get in week 22 related to the special right triangles is this one. A sign is in the shape of a rhombus with a 60-degree angle and sides of 12 centimeters long. Find its area to the nearest tenth. So we're dealing with an area problem, so we always want to write down the area formula that applies. The formula for the area of a rhombus is simply base times height. And we're told here that all of our sides of our rhombus are 12 centimeters. And so we can label that as well. Now, one of the things that throws students off is that they don't see the relationship of a rhombus to the special right triangles. Well, the key is that we're told that one of the angles of this rhombus is 60 degrees. So this angle is 60 degrees, and we're going to use that fact to find what we're missing. We're missing the height of our rhombus. So immediately when we label it, draw the height of the rhombus, we see that we're dealing with a 30, 60, 90 triangle. And I know that the hypotenuse of this 30, 60, 90 triangle is 12, which means the short leg right down here at the bottom is going to be half of that. That's 6. And the height, the long leg of the 30, 60, 90 triangle is going to be 6 times the square root of 3. Okay, so using the 30, 60, 90 ratios, the hypotenuse is 12. Then the short leg is half of that, which is 6, and the long leg is 6 times the square root of 3. And now we can immediately see, hopefully, that the area of this rhombus is equal to the base times the height, which is 6 square roots of 3. So using our calculator, we do 12 times 6 square root of 3. And that will give us approximately 124.7 centimeters squared. So that's how you can use 30, 60, 90 relationships in other contexts. Now, one other really common problem that I get in this section is related to this problem. Give me just a moment to pull it up. And it is to find the length D in simplest radical form in the diagonal of a cube with sides length S. So find the length D in simplest radical form of the diagonal of a cube with sides of S. Now this is the most common incorrect answer that we get on this problem. Because we know we're dealing with a cube, the sides of a cube are squares. Okay, so we have a square on each face, and we have S by S because we know that each side has S value, and we know that's a 45, 45, 90, and so we kind of default to, alright, that's S times the square root of 2. But what we found there is a diagonal of the face of the cube and not the diagonal of the cube itself. So let's have a look at what a cube would look like. I can't draw a cube well enough, so I'm going to use a diagram here. Okay, let me erase these strokes. They're in our way. So if we are looking for the diagonal of a cube, what we're actually looking for is this part that goes through the center of the cube from one corner to the other corner. We're looking for that. So that's D. That's the value that we're looking for. We're going right through the center of the cube. Okay, now we are going to use triangles, so I'm going to do this little thing on the bottom here. And what that does is creates a right triangle that goes through the center of the cube. Now we do still know that each side of the cube is S, and because that's isosceles and the cube is all right, this is the diagonal, which is S times the square root of 2. This side is also S. Alright, so we're looking for D, and we know that the other two sides of this right triangle we're dealing with are S and S times the square root of 2. So this immediately throws us into the Pythagorean Theorem, where we have the square of the hypotenuse is equal to the sum of the squares of the other two sides. So a squared plus b squared equals c squared. So we'll have s squared plus s times the square root of 2 squared equals d squared. All right, so d squared equals, that's just s squared. When you square the square root of 2 and you square s, you get 2s squared. So d squared equals 3s squared. And then when you take the square root of both sides there, we end up with d equals, the square root of s squared is s, and the square root of 3 is what we're left with. So that's the length of the diagonal of that cube. So we're using in this case 45, 45, 90 relationship to find this side, the side there, the face of one of the sides of the cube, and then, or the diagonal of the face of one of the cubes, and then we use the Pythagorean theorem to find the diagonal in terms of S. Thanks, and have a great day.